Reflection. Okay, reflection is the bouncing back of light from the surface. Okay, so this is the surface and this is the normal to the surface. Normal to the surface is denoted by n. Suppose this is the incident ray. Okay, this is incident ray and this is the angle of incidence. So what is the angle of incidence? The angle between the incident ray and the normal is known as the angle of incidence. And when light ray incident on this surface, it bounce back to the same surface, and when it bounce back, it makes this angle r, which is known as the angle of reflection. Okay, so this is reflected ray, this is reflected ray, this is incident ray, and this is normal. So there are two laws of reflection. First is the normal, incident ray, reflected ray and normal all lie in the same plane. Okay, they all lie in the same plane. This is the first law. And second law of reflection is the angle of incidence is equal to angle of reflection. Okay, so this is known as reflection. The bouncing back of light to the same medium is known as reflection. Now refraction. Before we talk about refraction, we should know what is denser medium and what is rarer medium. Okay, denser medium means slower speed of light in that medium, means denser medium, and that means high refractive index. Okay, and rarer medium means in rarer medium there is faster speed of light, and that means the low refractive index of rarer medium. Okay, so in refraction, light ray goes from one medium to another medium. When light ray goes from one medium to another medium, it either bends towards the normal, okay, or goes away from the normal. Okay, either it bends towards the normal this way, or either it goes away from the normal. So we will see in which case what happens. Okay, so now this is the boundary which separates the two medium. This is the normal to this surface, this boundary. Okay, suppose this is denser medium and this is rarer medium. Okay, so this is the incident ray, this is angle of incidence, and when light ray goes from denser to rarer medium, it goes away from the normal. Okay, this is the angle of refraction. Okay, and now we will see what happens when light ray goes from rarer to denser medium. Suppose this is rarer medium and this is denser medium. This is the angle of incidence I. Okay, and what happens here, as the light ray goes from rarer to denser medium, it bends. Now we will see what happens when light ray goes from rarer to denser medium. Suppose this is rarer medium and this is denser medium. This is the incident ray, this is angle of incidence. When light ray goes from rarer to denser medium, it bends, it bends towards the normal this way. Okay, so this is the angle of refraction. Now there are two laws of refraction. The first law is the incident ray, the refracted ray and the normal, this is the normal, all lie in the same plane. Okay, this is the first law. Incident ray, there are suppose laws of reflection. First, the incident ray, the refracted ray and the normal all lie in the same plane, and the second law is sine of angle I upon sine of angle R is equal to refractive index of second medium with respect to first. Okay, so this is also known as Snell's law. This is also known as Snell's law, and this is the second law of refraction. So this is all about refraction. Okay, Today we will see what is total internal reflection. Okay, in total internal reflection, this is the boundary which separates the two medium. Okay, this is the normal to this boundary. This is normal denoted by n, and this is a incident ray. Okay, incident ray, and this is the angle of incidence. Okay, angle of incidence is denoted by I. Let us suppose that this is the denser medium and this is the rarer medium. Okay, and we know that when light goes from denser to rarer medium, okay, when light goes from denser to rarer medium, it goes away from the normal. In this way, it goes away from the normal, and this is known as the angle of refraction. Okay, so this is simply refraction. Okay, light incident on the boundary of which separates the two medium, and the light either bends towards the normal or goes away from the normal. So this is simply refraction. We know this. Okay, now what happens, suppose if we increase this angle of incidence. Okay, if we suppose increase this angle of incidence, then what happens, the angle of refraction also increases. Okay, now suppose if the angle of incidence is such that, if the angle of incidence is such that the angle of refraction becomes 90 degree. Okay, this is the refracted ray and this is R. Okay, R is equal. Then this angle of incidence is known as critical angle and it is denoted by IC. Okay, so critical angle is that angle of incidence at which the angle of refraction becomes 90 degree. Okay, and suppose if light incident on this surface greater than the angle of critical angle. Okay, here the angle of incidence is greater than the critical angle. Okay, here the angle of incidence is greater than the critical angle. Then what happens, this R becomes more than 90. More than 90 means it goes back to this surface. Okay, this is R now. Okay, so this is known as, this condition is known as total internal reflection.